I picked up two Fluke 8840s from my surplus store, and this is one out of them. And I cleaned this guy up, powered it up, and you can see the reading. The display is all over the place. It's even giving me overload without any input. So let's see if we can fix this guy. That's the interior of the instrument. And I can see some burn marks here. That's interesting. Otherwise, it all seems to be good and intact in shape. Like any other instrument, you have power supply test points for all the output rails. So I'm going to probe one or two of the output voltages and see how they're doing. Since I see this chip or whatever component out there is burned or hot or whatever it is, I would probably try to disconnect this true RMS option PCB first. So this is the PCB, or this is an option for true RMS AC measurements. So I'm gonna pull this guy out of the circuit. Okay, to take out the true RMS assembly, you have to pull these four plastic plugs off. Just a little bit of a flimsy arrangement, and that's where it comes up. So it looks like there is a power connection going into that board. So let me disconnect that, and here it is. And the chip which was getting hot is supposed to be the AD41648. So this is the whole assembly. So I'm going to pull this out because this is required only for the AC option. So I'm going to run this guy without this board and see what's going to happen. Let's power up without the AC option board. Nope, it's still broken. And if you observe, the display is actually flickering a little bit. It looks like it's trying to hold on, but it's I suspect some sort of power supply issue. So let's check that. I was checking to see if there is anything which is getting too hot on the board, and apparently this regulator is really warm. That's a 7805 for the main plus 5 volt rail. That guy is getting really hot. So the power supply test points are right here. The key ones: plus 5, plus 30, minus 15, and plus 15. So let's measure them. Remember, the chassis is not the ground for the measurements. You have to use one of these grounded pads, or one of the ground points from the PCB to do the measurements. Okay, let's measure the rails, starting with minus 15. Good. Plus 5 is at 4.8. Not bad, wouldn't complain. Plus 30 is slightly over, but I guess it's still within the tolerance. And plus 15, there you go. Plus 15 is just 11.2. That's interesting. Now there are two regulators for this, which is the standard 78 or 79 series 3-terminal regulators. One is sitting over here, and the other one is right here. So what I'm going to do is I'm going to measure the input to these regulators because they share the same bridge and the same tap from the transformer. So let's measure both of them for the input and output voltage, just to get a feel of if it is loading the whole thing or if there is something funny with the input. And I'm also going to measure or look at the output from an oscilloscope to see if there is bad ripple. Okay, let's measure the negative regulator. That's input to the 7915, which is about 22 volts. And of course we know the output is at 15, so that's good. Now let's try the same for the positive regulator. The output is at 11.2 and the input is 15 volts. So the input itself is a bit low. That's a bit surprising. So let's probe the same using an oscilloscope. That's minus 15, not much of ripple. Plus 5, kind of clean. Plus 30, clean. Ooh, that's a plus 15 output, and you can see that's badly distorted. That means there's something happening, there's something funny with the plus 15 volt input itself. So let's dig around that. It is a bit surprising to see that this single capacitor is a different type, whereas these two seems to be from factory. And this is the capacitors for plus 15 regulator. Let's go to the rear side of the instrument. You have to pull this power switch connector out and then take this covering sheet off. That's how you get access to the back side of the PCB. What I'm going to do now is to test the output from the rectifier. Probably I'll even pull out the filter capacitor to see how's that one doing. So let me take out the filter capacitor, which is C605 first, and see what's the incoming waveform so that I get an idea if the bridge or the diodes are good, and then we will move from there. Surprise, surprise, surprise. That's the 470 microfarad 50 volt capacitor. That's dead. Well, let's test the rectifier anyways. Okay, let me probe the capacitor terminal, and I have a full wave rectified waveform. So my rectifiers are good. That's how the replacement goes. Now I'm going to test the voltage. Okay, let's test the voltages. Plus 15 is 14.9. That's good. Let's see how's the ripple on this line. Clean. Absolutely no ripple. So that was just one single stupid bad cap. Well, we don't know. Let's test the meter now. Okay, that looks promising. At least the display is not jumping around. The AC will give me the error because I've removed the RMS AC RMS module from this. Let's see how the resistance is. Beautiful overload. Milliamps 0, AC milliamps because the AC module is not there. I'll insert that next, but let's do some basic testing to see if it's good. So there it goes, and let's start with testing some resistance, which is going to be my own body. 1.9 meg. Yeah, it's a bit low because there are a couple of BS inside. Let me try one of the resistors which I use for anything and everything. Haha, beautiful. That is working. Let's do some DC voltage, and that's going to be coming off one of my power supplies, and let's see how badly that's doing. It's about 4 volt. Amazing. That's what I'm sending from the power supply. This is the true RMS module, which is an option used for AC measurements. So I'm going to insert this guy back, and let's see if it's going to power up. As we've noticed earlier, there seems to be some burn marks over here, but I think that's because the chip is getting too hot. Anyways, I'll put it in and then we will try. Okay, AC option is in, and time for us to test and see if it's going to work. Sorry for the poor lighting. Unfortunately, it's a bit late in the night, and I'm still poking around with these things. So let me go to AC. There's no error message now. Let me apply an AC input voltage from AC transformer, and oh yeah, that's the 12.6 out of my Heathkit 2717. It's about 14.7 because there is no load, but hey, that's pretty awesome. So all it took was just one capacitor. Okay, I've installed all the bells and whistles, and it's up and running. Now for comparison, let's put this guy alongside my Agilent or HP 34401 and see how far the calibration is away, close, or whatever. Of course, I know this is not warmed up, and it's not given enough time to heat up and reach the calibration, but still I want to know if it's really off or is it somewhat close by. So let's give it a try. Let's start with the DC voltage test. I'm going to apply the same power supply which I've used before to measure the voltage. 4.01921. Okay, now let's use the Fluke and see how he's doing. That's the display on the Fluke. I'm going to use the same input, 4.0186. Let's try AC next. So I'll switch this guy to AC, measure the same AC source which I've used before, and that is reading about 14.78. Okay, now let me go to my edge length. Sorry for the bad angle. Put it into AC, 14.767. Now let's try measuring the resistance. Starting from here, I'll use the same standard reference resistor which I've been using all this while. This 39 ohm, 39K. That's about 41.143K. Let's come back to the Fluke, put it into kilo ohms and measure it. 41.062. So that's so resistance is not all that great accurate. That's all for this guy. And now I'm going to get the next one. Okay, this is the second meter which came in the same lot. I thought I might take a bit long to fix the first one, so I didn't even clean this one. But now since I was able to fix the other one a little bit fast, let's power this guy up and see what's going to happen with this one and see what's wrong with it. Also, I wanted to show you how bad these things look when I really acquire them. It takes substantial amount of time to clean these things up to start with, to be honest. But anyways, let's go ahead and pop this open. Like the other one, I'm going to take out the True RMS option board out of this. I don't want that guy sitting there. Okay, remember to push this pin down before you try to pull it up. So you need to, insert your finger down below and then push this pin up and then you pull it out. Otherwise it's going to break the plastic. Let me measure the voltages. So that is minus 15, all good. 4.9 for plus 5. 29.4 for plus 30. Plus 15 is 12.32. Okay, I'm going to check the ripple for all the power supply rails just to confirm if there is something wrong with it. These are the points I'm measuring. So let me start with minus 15, all good. Plus 5, all good. That is plus 30, all good. Haha, plus 12 is, sorry, plus 15 is messed up again. So in this guy, I'm going to actually replace all the 3 rather than taking a chance with the other 2. I have removed all the 3 caps from the second Fluke. It's a made in Japan. This is the other one. And this is the third one. Let me test all 3. Okay, this is one of the 470 microfarad caps, reading about 100 microfarads. This is a second 470, reading about 511. Not bad. And this is the last one, the 330 microfarad 100 volt, which is about 329. So let me replace all the 3, put it back together, and then we will test. Okay, I have replaced all the capacitors, and I guess the reason why this single capacitor, which is for the plus 15 volt, goes bad is because this is sitting right next to the heatsink. So I guess it was a little bit of a design issue. So I think because this is too close to this, it's going to evaporate the electrolyte inside the cap and make it dry and go bad. So anyways, in any case, I've replaced all 3 and let's see if it's working. Let's do a basic test where I'm going to short the input. Okay, that seems to be sensible. Now let's do AC volt. It'll give me the error because of the RMS module is not in there. And let's do resistance, and yes, let's do the basic test once again with the same resistor which I've used for the other meter. 40.8. Okay, let me do a DC volts test with my DC power supply. That's not bad, reading about 4.01. And now let me insert the RMS module and put all the bells and whistles around this guy and test this one. Okay, I've put its clothes back on, and there you go. I'm gonna remove and clean all these labels and rest of the chassis. That's gonna be later, but to start with, okay, when I short the inputs, it's giving me 0. Let's see if the AC function is working since I've added the true RMS module. Yes, that's working. Let me test the voltages, and I'm gonna apply the same AC source to this guy, 14.6. So that's also back to life. Okay, here we go. I have both of them stacked one on top of the other, and both are working. Let's do a measurement in terms of comparison. Before that, a quick point: the meter below looks a little bit dim. That's mainly because of the lighting, but when I look at it, I don't see much of a difference in the VFD brightness. So let's apply a DC voltage and see how these guys compare with each other. 4.0187 and 194. Of course, these guys are not warmed up, so I'm not gonna say they are drifted or whatever. They need at least 30 minutes to 1 hour warm up before they come up to their spec, but they're not drastically off. Now let's try AC. I'm going to switch both the guys to AC and apply AC voltage from the same source which I've used before, and you can see the difference, 14.59. So all I had to do was to replace technically just 2 capacitors. In case if you find any 8840 with these weird symptoms, you know what it is now. Thanks for watching, and take care.